Next up, we have our last talk before the break, Sandeep Raghuwanshi from Razorpay. So he's going to talk about strategies for striking the perfect balance between sustainability and scaling. So, cool. So over to you, Sandeep. Yeah.
Hey, hi everyone. I don't think so. We are having enough energy actually. I'm under pressure a little bit because I'm competing against the India-Pakistan match. And if I'm not able to deliver to that level, I think you guys might not come to the next meetup. So yeah, we have talked about on the organization level how you can uh, measure your carbon emission or all those things. But as a individual contributor, how you can contribute from your end, or maybe can make it up to your next promotion, basically. So this is kind of a personal pitch as well. Why you should hire me? Because we were able to save somewhere around $5 million per year by optimizing our cloud cost on the various levels, basically. So this is a story, and this begins actually whenever there is a new startup comes in, and there is a lot of um opportunities, and a lot of customers are onboarding, and they have a lot of workload. So management starts building up the stack, and as an individual contributor, you also uh, ramp up the stacks and stacks of the infrastructure, and by serving the those requests, or maybe those clients, you get promoted, your manager congrats you, and then basically this happens. Basically, they get ready hit hard by the cloud cost, and that's how they goes on. And then there are chaos in the organization, that how to contain the cost, basically. And that's how there's a story, I mean, kind of climax. So we goes on to next level, basically, how we can categorize this thing. So the major cost consumption happens on the four places, at least for us, basically. And that is AWS, that is our cloud provider, and then Kubernetes, and the monitoring and logging, basically. So all of them basically deployed on AWS, or kind of under umbrella of AWS, or the cloud provider, basically. So if we are able to contain the cost on the top level, I think that comes down to on the bottom level as well. So on AWS, actually, we were spending somewhere around in millions. And when we thought of containing the cost, and when we were able to kind of narrow down where we can just, without compromising the efficiency and the workload and the business, what we can optimize, basically, and that is compute, network, storage, and the Graviton is actually another initiative from AWS side. So these four parts, basically, we categorized, and we worked on this for a month, and we were able to save somewhere around at least $1 million by containing these costs. On the compute side, basically, so what Razorpay does is actually we kind of run most of our workloads on Spot instances. So, I mean, I'm not going to explain you Spot and all, because that's how, I mean, DevOps engineer or the developers actually nowadays, they know. So that's how. So, but when we are running on the Spot instances, basically we have a fear of losing on the workload, or maybe the eviction, and how we contain that thing, or we prepare for that thing, basically. So to contain that thing, or I mean, we prepare for that. We use two custom CRDs, basically. One is node termination handler, and another is node termination healer, basically. So whenever there is a, I mean, node gonna be terminated by AWS, this sends signal that within 2 minutes your node is gonna be terminated. So we catch that signal, send it via event manager, and then scale up in the on-demand, or maybe another Spot instance, ESG, basically. And on top of that, we use basically cost optimize and uh, cost optimize method, on the ASG side. So whenever we are scaling on the ASG or maybe on the data center layer, it finds us the best cost optimized node, easy to instance basically. So uh, to utilize that, basically, we need to have at least 4 or 5 numbers of node type, C category or M category or whatever is the use case. So it will give you the best available EC2 instance, basically. And then we encourage every new service. We have somewhere around 500 or 600 services. So whenever we have created a template so that any new application which is coming up, actually, they follow the same pattern, which we have kind of templatized it. And then on the CI side, I mean, on the build, most of our instances are on the GitHub runners, and they are basically running on the Kubernetes. So we are utilizing the custom CRDs there as well. Um, on the network side, basically, how we were able to contain is actually, we were able to find out where we are sending the data across the availability zone or the regions, basically. So that's how we contained our net cost or the data transfer cost, basically. So we encourage to have the workload or the net gateways or whatever things we are running in a same availability zone, basically. And another thing is storage, basically. So what happens whenever we have a new node or any Kubernetes cluster, basically. So they kind of attach those storages and they are lying around. So we wrote some custom scripts to find out whatever the usage going maybe on the month by month basis or maybe day by day. And then we were able to terminate them and kind of clean somewhere around 200 TB of data per month, basically. So yep. And the Graviton is actually a new initiative, basically, from AWS. So nowadays, I mean, we might have heard about the NVIDIA chips and all those things. So same thing, AWS has come up with the Graviton instances, and they are promoting it very heavily, and they give huge discount on them, basically. And those Graviton instances are basically, they are I mean, ARM64 processor. So you have to manage your workloads as well in order to get somewhere around 50 to 60% discount compared to the EC2 instances. So yeah, that's on the AWS side. If anybody has any question. So, I mean, as you know, I mean, anyone who is offering a new service, definitely they are going to give that. But honestly, why they, at least 30 to 40% is going to be there, because first, they have this in-house thing. And another thing is actually, I mean, ARM is actually licensing it. So if they are buying any Intel or AMD processor, they have to pay per processor. But this thing is their in-house, and they got the license. So license fees, they have already paid it. So I mean, if they have to compete in the market, definitely that has to be 20 to 30%, because if anybody is onboarding on Graviton instances, they have to make changes in their application itself, because that is RISC processor, and everything is not working on RISC, basically. Sorry? Mm-hmm. No. It's not a smooth transition, because honestly, I'll tell you, we have initially, when we onboarded some of our workload, there was so we onboarded on a GitHub runners, basically build if it is taking long time rather than serving the clients. So some of the builds, they were taking somewhere around 50 to 60% extra time. So in order to fine tune them, we have to download those, I mean, in build, those, I mean, compatible packages during the build, and it took some time. Yes. So actually, that's why I said we onboarded at least 50%, because whosoever is not supporting, we cannot just abandon them and, I mean, run behind the cost. So that. Yeah, both. So, whenever we are saving cost, basically, so Spot runs with the on-demand, and Graviton runs with the normal Intel and AMD CMDs, basically. So whenever we are auto-scaling it, basically, we try to find if it is available on Graviton, Spot, and then on-demand. So that's kind of fallback approach. Anything else on that side? Okay, cool. The next one is actually Kubernetes. So our organization's whole workload runs on Kubernetes basically. So when we were able to contain the cost on the AWS side, now it boils down to the Kubernetes, how we can save cost on the tiny pods or whatever over provisioning or a node or a storage we are having on the Kubernetes level basically. So these are the four categories basically we worked heavily on, and all of them I mean, the cost saving done by the either writing custom script, custom CRDs, or using some open source tools. We did some POC on the Cast AI, Carpenter and all, but we found out that it is better to write our own custom CRDs or scripts basically. So we do not use them basically. So the bin packaging is actually when we, I mean, schedule a pod or maybe n number of pod in a deployment or in a namespace basically. So it goes on to a n number of node, and there is a unutilized space or maybe on the CPU remains on those machines basically. So how we can fill that space? So suppose in this room basically we have a lot of chairs available. So how we can fill those chairs? Something like that we did for the pods basically. So 100% utilizing the nodes maybe on the memory or on the CPU side. So that's how we, I mean, bin packed the whole nodes basically. And then the imbalance, I think DevOps engineer or as a Kubernetes user, you might be aware that Kubernetes only cares about the scheduling. It doesn't care about the de-scheduling basically. So what happens when you create a new cluster, over the years, it becomes very imbalanced, and some of the pods might, some of the nodes actually might be having 10 to 15 nodes, or some of the nodes might be having 40 to 50 nodes. So that's how, if you have two clusters running in your workload, and then cluster of clusters basically, that's how you might feel that one of the cluster is performing well and another cluster is not performing well. So that's the thing, it gets imbalanced. For that, we have multiple solutions available, but the open source descheduler is the best choice. So we use that, and we ran, wrote our own policies based on the node or maybe on the pod or on the workload priority. That's how we, kind of take care of the imbalanced Kubernetes cluster. And then the over provisioning, because not everything is being supported by the auto scaler. So in some cases, we have to do the over provisioning, because as a payment organization, we have to be really prepared for any unprecedented flow of traffic. So that's why we do the over provisioning, where we run the dummy pods on the few of the machines, so that whenever the real demand comes in, we kind of evict those pods and the actual pods come in. But by taking care of the bin packaging imbalance, we were able to kind of get rid of the over provisioning. And we also wrote our own custom CRD, so that we can take care of the vertical scaling and the horizontal auto scaling basically. And then the tuning request and required memory or the CPU basically is the huge aspect in the Kubernetes, because we might think that a pod which is using 250 M and maybe 0.5 CPU is actually a tiny pod. But if you multiply it with maybe a 1 lakh pod or 2 lakh pod, it becomes huge. So if we are able to, kind of reduce at least maybe 10 M or 0.15 per CPU also, and that becomes huge, because we run kind of how much 10,000 nodes, and we were able to save somewhere around 500 to 600 nodes basically on that part, while fine tuning the request and required resources on the Kubernetes side. So any question on that? Yeah. Sorry? Yes. No, it's generally available. It's under Kubernetes umbrella. So Carpenter, if you use Carpenter and Cast AI in combination, they give you the best available node basically. Carpenter is for your scaling and finding out the best node for you. And Cast AI is something ki, if you say, I want only the spot instances and I want that particular category only. So that gives you that. And we wrote some of the custom CRDs as well, so that we kind of run them in parallel and kind of combination. So we kind of bin pack the whole node.
Fall short for you? Like, why go to Carpenter or
So
Fast
the
AI in the first place?
default bin packing is not happening because, as I said, Kubernetes only cares about the scheduling, and over the years, your Kubernetes cluster can become very imbalanced. If you're not believing me, you can just, I mean, do the experiment on your own Kubernetes cluster.
Got it. Okay, thanks.
If we are using the, the spot instances in Kubernetes clusters, let's say if an instance goes down, you got a terminated thing, then the workloads has to shift to one different node, and then a new node has to be provisioned and it has to go back. So how we optimize it? Because you are using a different sized instances.
Yes.
Or
No, so that's what I said. Ki we use two CRDs for that: node termination handler and node termination healer, basically. So whenever a node is about to terminate, AWS will send you notification 2 minutes before the termination, actual termination, and you have to catch that and I mean pass it through the event manager and event bridge. Or whatever notification you prefer, basically. So during that 2-minute duration, you have to bring up a new node, evict those pods on that particular node, and then bring up that particular workload on the new node, basically.
so that's where we are using the over provisioning and all. Or
No, over provisioning is something most of the organizations which are not really sure about how the traffic flow is going to be. So today is actually India-Pakistan match. So if you're using Dream 11 is a huge client for Razor Pay, basically. So we are not sure if 10 lakh people are going to use Dream 11 and they are going to buy, or 1100. We have good analytics about that, but there has to be a room, basically 5% to 10% over provisioning. So we do that for basically to cater that demand, unprecedented demand, basically, which I mean, the kind of corner case.
because provisioning instance and getting the registry, container images from the registry and all takes time, right? So in a 2 minutes time, it is really short time to provision the. If it happens for 2 instances, if terminated in the same time, it and all like complications, right? So how you guys manage? If it is a production or a?
Yes. It's the production. 60% of our production run on the spot instances,
cool.
and 2 minutes time is I mean
really
huge
critical.
time. I'll tell you. Basically, if you use pre-warm instances on AWS, that instance will come up in 30 seconds.
Okay. So you have some, hot cook images,
Yes.
images, instances.
So we kind of run a initiative in-house, which is kind of golden images, which is not kind of the multi-layered and all those things being taken care. So image is neat and clean, and then your instance is pre-warmed, and 30 seconds it is coming up, and then 30 seconds more for that. And then we have traffic ingress layer. That takes somewhere around 10 to 15 seconds. So 1 minute, 35 seconds around was the benchmark for us. We were able to bring a new instance in peak of the peak time, basically.
Nice.
Imbalance of Kubernetes cluster over prolonged usage? Like, how is time of usage anyway related to like imbalance?
So-
imbalance of what? Workloads?
Yes. So basically, what happens generally, I mean, whenever you create a new cluster, and over the years, what happens, you start using HPA and horizontal autoscaler. Now what happens, ki your scheduler, it just finds the particular required space or the CPU, and it assigns that particular pod to that particular node, basically. It doesn't care about whether you are having 10 nodes or 10 pods or 50 pods. It just needs that space and that particular required resources for that particular pod. So if you are not having something which is taking care of that particular scheduling, that, okay, boss, here we have 40 pods, and on another node we are having only 10 pods. That needs to be balanced out somewhere. So that's
So,
what is
does
the
it come with the assumption that over the years you have not rolled out any updates to deployment? Because when you roll out updates and the pod restarts, it will also rebalance as well.
It rebalances, but when you are running somewhere around 20,000 or 50,000 pods, you don't really go on every node, basically, on day-by-day basis or monthly basis. So there has to be something automated, and that's what DSQL does for us.
Okay, yeah, we'll discuss more.
It's easy to, I mean, check whether we have 50 pods or 10 pods or and all those things in a small cluster. But when you are running 2,000 nodes and somewhere around 50,000 pods in a particular cluster, it becomes really hard to go and check on everything. So that was AWS and Kubernetes. And the next part is actually our monitoring, because when we monitor that level of workload, it comes with the huge number of sample size, metrics, and the storage, what we do basically. And so we were earlier, we tried with OpenTelemetry, Thanos, and all those things, but we were settled with the Victoria Matrix as our time series database, basically. So why we chose Victoria Matrix, actually, because we wanted to have a retrieval and the analysis process really fast, and Victoria Matrix really gives us the embedded comparison, the compression algorithm, which kind of take care of the metrics and the rest, or on the basically on the go, basically on the network layer. So that is there. And the another part is actually, we had to take care of the cardinality of our matrix. So we are not putting multiple values for a particular matrix. And then there was a huge initiative so that we can contain the sample size of a particular matrix. So in a minute or in a 5-minute duration or 10-minute duration, whatever sample size we choose, how much matrix we are dumping on the Prometheus side, basically. And then we kind of came up with the idea of monitoring the monitoring system. So we on top of our centralized monitoring system, we kept another monitoring system with the Prometheus, so that we are not losing out on anything, and then we are kind of taking care of the monitoring usage and all those things. So there is a actually tiring we did for this. So what we did is actually on the go we use hot storage for 7 days, where we do all the metrics and all the alerting and all. So that is coming from the hot storage, and then after 7 days it moves to the cold tier, and then after 90 days it moved to the archive tier, basically. Sorry if you have any question on the monitoring side. Okay, cool. I have this. The next is logging, actually. So as a developer or DevOps engineer, you cannot just rely on the metrics or the APM tools. You have to go really on the bottom layer and see what your application is doing on the log side. So logging plays an important role, and there are applications which are dumping GVs or GVs of particular logs for a particular request, basically. We have seen this issue, and we were able to, contain that thing by getting rid of the verbosity of the logs. And then on the node side, basically, on the Kubernetes node, if we are collecting the logs, you have to run some daemon sets or some agents, basically. And those agents, if those agents itself are taking up huge space, or they are, hogging up memory, or there is a huge CPU shoot up happening on those side, then that also you need to take care. So that's how we came up with the usage of Fluent bit instead of Fluent D, because its architecture and the language it is written is, it kind of reduces the memory hacking and the CPU consumption on that part. And then verbosity I've already explained. And then the same thing which we did, the tiering part on the logging side as well. So we made 3 tier, hot, cold, and the archive tier. So whatever is happening for current, maybe for the 7 days, we keep it in the hot tier. And the querying is also very smart, because we keep everything on the elastic cache. And then it moves on to the cold tier, where we keep everything on the S3. And then the archive tier is basically the data lake, where data rests in the rest in peace, basically. So, yeah. Yes, I'm done. Thank you. Sorry, I had to rush in for monitoring and logging. If you need, if you have any question, I can go back to the slide, and maybe we can just take 2 minutes more, if you have something. Sure, no worry, yeah.
So did you also try to explore Logstash or maybe Loki for the logging part?
Yes, yes,
And why
we
do you
did
prefer?
that thing, but I mean, so after writing so many CRDs and custom solutions for ourselves, basically we come up that, okay, for logging, we'll go with the SaaS solution. So we, I mean, kind of juggle between two of the SaaS solutions, and then we finalize one of the solution. They actually, in the backend, they keep this thing in the Elastic Cache and the Logstash. They are using that thing only. We ship from our end, from FluentBit to the centralized agent, and then it goes on to this. So they are the same part, but it's just that the architecture and the language they are written in is different. So FluentBit is written in Rust or R, if I'm correct, and FluentBit is, I think, in Go, basically. So that's how, I mean, the architecture is different. And
So you guys use any buffering in between the logging part? So, FluentBit takes a buffer before sending it to the last centralized.
yes, yes. So that does actually. So FluentBit will send the data from every node to a central gateway. From there, it reflects into the Elastic Cache, basically.
So you guys using any, messaging broker or something like so?
No, actually, messaging broker, Kafka, and all. So so there are two things actually. Whenever we need some critical data or the financial data, we send directly to Kafka and keep it in a hot tire, basically. And whichever is not that critical, we keep in the usual way, the FluentBit and the sample gateway and all.
You talked about like Victoria matrices. So did you face any discrepancy issues with Victoria matrices? And if yes, then how did you deal with them?
No, and so the Victoria matrix architecture itself is really great. So it gives you the flexibility of insert, select, and storage. So that kind of itself is decoupled. So you can contain n number of things on and play. Suppose your storage is having some issue. Suppose your select is having some issue, or maybe your insert is having some issue. So, and you can keep, this is, kind of 3-tier, and you can keep n number of nodes for them. So wherever you are having some issue, you can bring that node down, and then rest of the cluster works really fine.
Cool.
Thank you, guys.
Thank you, Sandeep.